Okay, so we're going to start with discrete probability. And discrete probability is basically using numbers that are countable. Okay, now what does that mean? That doesn't mean that you decimals. No, I didn't say the probability. I said the events. The event that will be discrete. The event will be discrete, meaning like households. I use households a lot because you can't have 2.5 households. So when I'm talking about discrete, hold on just a second. One more. There we go. When I'm talking about discrete, what the? Oh man, why is it doing that? I'm not supposed to do that. Great. Now the daggone markers don't work. When I'm talking about discrete, I wish I could just teach from home. When I'm talking about discrete, I'm talking about countable events, such as households, such as the probability of one child.
Hello?
Hello, is everybody still here?
Yes, now I hear you.
Yes.
Okay, what did y'all just see? Did y'all just see the computer blinking on and off, or what did y'all just see?
No, it was still just on that screen of the textbook.
Well, my computer just went crazy and started blinking like every millisecond for about 10, 15 seconds. It was just blinking on and off. I don't know what the heck. Okay, I'm sorry. Let me go back and see if I don't know what's going on. I checked everything out before class started. So I don't know what's going on. Let me try this again from current slide. So again, let me see if the I just won't try that no more. Evidently, something's going on with the pen, and I'm just not going to use that. So let me go over here and get out of the, every time I try to use that pen, it goes crazy. So I'm just going to take the whiteboard off, and I apologize. But anyway, I'm going to move down to this. Now, instead of talking about decimals, the households, you cannot have 2.5 households. You cannot have -5 households. You cannot have 1.2 households. So the events, and I want you to write this down here, the events will be discrete. The events will be discrete, meaning that they're going to be positive. There's not going to be any decimals or fractions on the events. And you're going to go from 0 to ever how many whatevers. So I like to use households because, like I said, you cannot have a decimal or a fraction household surveyed. Kind of like having 5.5 people surveyed. You can't have 5.5 people. So when you're talking about a discrete random variable, most of the time you're going to be talking about the event. Probability of 4 households watching the football game. What is the probability of 5 couples having 2 children? Okay, both of those are discrete events. Now, with discrete events, you're going to have to be privy to inequalities. And I can't write on the board, but I should have wrote down those inequalities Friday on a piece of paper and shown them to you. And those inequalities are going to define at most and at least, more than or less than. And those play into some of the questions of your homework and your test. What if I said at least 1? Well, at least 1 means that the lowest number is 1. So that means 1, 2, 3, 4. So the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. Can't do this anymore. Okay? Now this is the way that the probabilities will be. Usually the probabilities will be continuous, just like always. The probabilities will be in terms of a fraction or a decimal. So they include fractions like 1/2 or 3/2 or 7/8 or 15/16 or 2.6. That's your probabilities. And they're going to look, let's see if I can show you. Well, there's some examples. Notice with discrete, the word number appears. With the word continuous, the length. Number, discrete. Length, continuous. Now, I don't know if you're writing those down. Those would be good examples for standardized tests, though. Not necessarily my test, because I asked you that back in chapter 1. What is discrete? What is continuous? So I've already asked you those questions. They may show up on the test, but I know they'll show up on a standardized test. Number, discrete. Length, continuous. Length or measurement, continuous. There is a probability distribution. Write that down because this is the example that we're going to be using.
I don't know if it's just me, but I can't see your screen.
Everybody else, can you see the screen?
Nope.
No.
I have been talking for about 5 minutes and none of you said a word. Thank you for finally saying something. Do y'all not understand the word communication? Oh. Okay, thank you for communicating finally. I believe that was Miss Stewart. Was that Miss Stewart?
Yeah.
Thank you. Oh, man. Let's try it. Let me present screen again. I'm sorry. I don't know what happened. I don't know. I came in, I turned on this computer just like always. It's damn Russians is what it is. Present screen. Okay, tell me if you see my screen now.
Yep.
Okay, somebody else tell me if you can see it, just so I have two people.
Yes.
Okay,
Yeah,
thank you. Thank you for the communication. Okay, that is a probability distribution. So you need to write that down because on the left side, I need you to write over that X right there. Since I can't write it, I need you to write event. X is the event. 0 household, 1 household, 2 household, 3 households, 4 households, 5 households. Or 0 boys, 1 boy, 2 boys, 3 boys, 4 boys, 5 boys. Or games in a series. I mean, what's the probability of them winning 1 game, 2 games, 3 games, 4 games, and 5 games? The P of X on the right is the probability of that event. So if you read the probability distribution that I have on the screen right there, I have the event of 0 happening and the probability of 0 households watching the football game is 0.06. The probability of 1 household watching the football game is 0.58. The probability of 2 households watching the football game is 0.22, and so on. Now, there are 2 tests that you need to check before you start a probability distribution. 2 tests, and these are the tests to make sure that they haven't given you a junky problem or a problem that can't be done. The first thing you do is you add up all the probabilities. When you add up all the probabilities, what number should you get? That means
1.
I want y'all to take a guess. What?
1.
1. So when you add up all those probabilities on the right, all those decimals, you should get 1. If you don't get 1, then it's not a probability distribution. The second test is that each probability has to be between 0 and 1. Whether it's a fraction or a decimal, it has to be between 0 and 1. So if you have a whole number other than 1, or if you have a negative number in the probability side, it cannot be a probability distribution. That should have been enough time for you to write down that probability distribution. Now, they're going to give you 3 test questions on the next 3 slides, so you might want to write them down because they're also good standardized test questions also. Okay, there's the 2 tests. The summation of the probabilities should equal 1. Each probability should be between 0 and 1. That is not a probability distribution. The reason it is not a probability distribution is because if you add up all the probabilities, you get 0.97. That is not a probability distribution. So if you got this on a test and the answers were the mean is equal to 0.2 or the probability distribution exists or the probability distribution does not exist, you would say the probability distribution does not exist because this added up does not equal 1. So that would be a good test question or a good standardized test question. And the answer is the probability distribution does not exist. Or is the following a probability distribution? No. The next example. This is not a probability distribution because you have a negative number for a probability. You can't have negatives. There is no such thing as a negative probability. Now, there's such thing as a negative correlation, but there is not a negative probability. What if I had 1.22 right here? 1.22 would not be correct because you can't have a whole number greater than 1 or less than 0. Actually, you can't have any number less than 0, and you can't have any number above 1. So the answer would be no. This is a probability distribution. If that's not the example that we had at the beginning, I don't know. All of them are between 0 and 1. And if you add them all up, you get 1. So I've already shown you like 5 test questions I could give you, or 6 test questions I could give you on 6.1 without even doing any math. Okay. You can graph it. I just want you to know that you can graph it. I'm not going to usually ask you to graph it. Some of the homework questions may ask you to graph it. But you can see if this is the middle right here, between 0 and 5, 2.5, is that the middle? It looks like a little bit of the data is on the left, so that means it's skewed right. So this one would be a little bit skewed right because a lot of the data is on the left-hand side of 2.5. And 2.5 middle because of 0 to 5. Half between 0 to 5 is 2.5. So make a note that you can graph the probability distribution, and you can get whether it's normal, skewed left, or skewed right. And in this case, it is skewed right. Huh. Ooh, I didn't know this was on there. Wonder where that comes from. I wonder if I could draw on this thing. But I bet I can't use can I use my pen? Yeah, see, it's still, something's not right. For those of you that wonder, I just drew on the bottom right-hand corner of the screen, and it put the mark in the middle of the screen. So that ain't gonna work. But I can use the pointer. Can y'all see? Well, where's the pointer? Where's the pointer? Can y'all see the pointer?
Yeah.
Oh, that's good. All right, let me erase this. How do I erase it? Just go to the next page, I guess. I guess this comes with PowerPoint. Oh crap, I've already done something I don't know how to do. I better just keep doing what I'm doing. Let's see. How do I get back to the cursor? Oh crap. I better just hit enter and go to the next problem. All right, write this down right here. The mean of the discrete random variable, or the mean of a probability distribution, is right there. Write that down. Mu of x is equal to the summation of x times p of x. Mu of x is equal to x, the summation of x times p of x. So you're going to take the first column of the probability distribution and multiply by the second column and add them all up. Okay, toggles on and off. Okay, so write that down because that's the test question. How do you find the mean? In other words, I will ask you to find the mean of a probability distribution. Now we're starting to get into the math of 6.1. This is your first test question that I would give you. What is the mean of the probability distribution? So in this case, 0 times, I would use this on a calculator. Let's hold on just a second. Pull up my handy dandy Excel spreadsheet. And I'm gonna make the letters a little bit bigger. And everything's gonna be centered. And I need to make everything a little bit more visible to y'all. There we go. And move that over here. And pull up the handy dandy publisher and make it smaller. And probability of x is 0, 1, 2, 3, 4, 5. And the probability of x is equal to 0.06, 0.58, 0.06, 0.58, 0.22, 0.10, 0.03, 0.01. So if I wanted to find the mean, I'm going to go over here a little bit. And I'm going to call this row x times p of x. That's equal to this guy. I'm going to do the first one in my head, 0, times this guy. That is copied down. I want you to make sure you put this in your notebook, because this is, if I was to give you 10 questions from 4.1 or 6.1, 8 of them would be like this. Okay, I want you to be able to find the mean and the standard deviation of a probability distribution. And now I add those up. And that is the mean of the probability distribution. Now, what does that mean? Well, we're finding the mean of X. So what is X? X is the event. So your mean event is 1.9, 1.49. So since we do not have decimals in this column, what would that round to? Well, that would round to 2. Okay, so I'm going to put equals 2. So what's the average event? 2. This is your average right here. I'm going to mark that green, because green, I'm just signifying, is an event, is the average. So 2 is the average. So if they asked you what the average, if this was households, then you would say the average is 2 households that watch the football game. What about kids? The average amount of kids that parents have is 2. The average, based on what we have here. So if I give you 10 test questions out of 6.1, 4 or 5 of them are going to be the what is the mean? And the rest of them will be standard deviation. And then 10, 20% would be like definitions like those 6 questions I gave you: discrete, continuous, and then is this a probability distribution? Okay, so the next thing we're going to get into is the standard deviation. So make sure, it's real simple, it's not hard. You just add them up. I mean, you just find the 0 times that, put it over here, and then add all those up, and that's your mean. Now, the reason I rounded it up is because most of the time, since these are discrete, you're going to round this to a discrete number. Okay, so that's a good example right there. They did it across, and I don't do it that way. I do it with a spreadsheet, because that makes a little bit better sense to people. So, and they got the same thing, 1.49. And of course, y'all know X bar is equal to all the summations of X divided by N. And I'm not going over this, because most of the time y'all can see, if y'all want to take, the following data represents 100 randomly selected customers in a single visit, 100 of these. So 1, 2, 3, 4, 6, 7, 8, 9, 10, and 10 this way. So you got 100 numbers right there. And they're going to want you to find the mean. There you go. Okay, now it just so happens that these are the same, 1.49. And there's the actual data, and here is the average. Well, it's really not the average, it's the best fit line, and it's usually right there at the average of 1.49. Okay, you need to write down the expected value, because you will see this question on a standardized test. Write this down. Because the mean of a random variable represents what we would expect to happen in the long run, it is also called the expected value. The mean is equal to the expected value. Expected value is something you will be tested on. Not, well, you will have one question on my test because of the standardized test. You will see the standardized test, and it usually is in the form of an insurance question. Write that down. Usually when they're talking about expected value, it's usually with an insurance question or gambling. Here's an example. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of a policyholder. That's the way it goes. These policies have premiums payments that must be paid annually. Suppose a life insurance company sells a $250,000 one-term life insurance policy to a 49-year-old female for $530 a year. According to the national blah, 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 the probability the female will survive the year is 0.99791. So you got two events happening. Survive, that's the event, and does not survive. So if she survives, the insurance company gets what? $530. And the insurance company finishes out the year and everybody's happy. What's this event? This event is what happens if she dies. If she dies, the insurance company loses $249,470. Now, how do we get that number? Because she paid $530 to the company. So the company got $530 out of her before she died. But they're going to have to pay her $250, but they got $530 from her. So this is the difference between $530 minus the policy. So that's your two events. Alive, dead. What is the probability that she's alive at the end of the year? 0.99791. What's the complement of alive? Dead. So what's the complement of 0.99791 to 1? 0.00209. And now, this is a spreadsheet question. You take this times this and add it to this times this. And you get $7.50. That's the expected value of this policy to the insurance company. Now, I can tell you right now, I don't see me putting a lot of these on the test. I might put one, but the only reason I'll put one is so you'll remember it for a standardized test, or you'll make sure you study it in the homework. Excuse me. And there, and I'm going to take a highlighter. Here is the formula we're going to use for standard deviation. I know something's wrong. This dadgum computers, when I get to the edge, it just takes it down to the right. Okay? So standard deviation is equal to the summation of x squared times p of x minus mu squared. That's the mean squared. We've already got the mean squared. We got P of X. What's the only thing that we don't have in that formula? That means I want y'all to talk to me. What's the only thing we do not have in that formula? We've got P of X. We've got mu, so we can square mu. We got mu. We got P of X. What do we not have?
X squared.
We don't have X squared. Thank you. We don't have X squared. Sorry about that. I was trying to make it look better. Things I do for y'all. There we go. All right, we do not have X squared. So I'm going to go back to my handy dandy spreadsheet. And I'm going to go over here and I'm going to do an X squared. So that's going to equal this raised to the second power. I'll copy that down. And now I'm going to do another formula right here. We're going to do X squared times P of X. So equals X squared times P of X. Excuse me. I'm going to copy that down. And we're going to add it up. And then we're going to subtract this squared. So I'm going to go down here, I'm going to put variance. Is equal to this number minus parentheses 1.49 squared. And that is my variance. And what is the relationship between the standard deviation and the variance? That means I want somebody to talk to me. What is the relationship between the standard deviation and the variance? Two words, starting with S, Q, U, square root. Or I'm going to raise 0.8699 to the 0.5 power. Either one will give you the same answer. And that is my standard deviation. So now I've got a mean of 2 and a standard deviation of 0.932. Is that important? Yes. Is that pretty much 80% of your test with 6.1? Yes. So what should you be able to do in 6.1? You should be able to find the mean and the standard deviation of a probability distribution based on what I've done right here. Now, of course, you can do it on your calculator, but it's going to take a little bit longer because everything's not, well, actually, you could do it and do first variable statistic. So let's go to your handy dandy calculator and let's do that. Let me get out of this right quick. And it's not letting me get out of it. There we go. Pull up your handy dandy calculator. I have to go to the computer screen to do that, and then I have to configure it. Sorry, but that's something IT should have to do, but I have to do this every time I pull it up. So, and we'll pull that over here. Bring up our handy dandy Excel spreadsheet, make it small. All right, so here I go. Stat, edit, and I'm gonna type in 0, 1, 2, 3, 4, 5. 0.06, 0.58, 0.22, 0.1, 0.03, and 0.01. Now we go to stat, calculate, first variable statistic, L1, and here type second, L2, and calculate. And mean is equal to 1.49, and sigma is equal to 0.93268. 93268. It's a miracle. Don't you feel good about yourself? You should. And that's what they got right there. Now they use a different formula. They use that first formula. I'm just going to show you that first formula right quick, because I don't want you to think they're doing something different. They're using this formula, and I use this formula because I think it's easier, but that's just me. So I don't use this formula. I use this formula. That's it for 6.1. Now, I want everybody to make sure you go home and work on 6.1 homework tonight. Let's check it and see if I got it open. My Labs Plus. Let's see, homework. And it is open, so you can go home and work on it tonight. As for class today, we're going to go ahead and shut her down. That's okay with y'all. I know y'all don't care. Yeah, Hubert, we don't care. Thank you, class. Appreciate the interaction. Stop recording.